Hello and welcome back to our tutorial series where we were taking a more complex garment and trying to set it up in Maya using a new carbon garment processor unwelded using Clo inputs. In the previous video, we have set up the trench coat in Clo, verified the setup and exported it, and now we can get started. Before we dive straight in, please make sure you have your carbon plugin installed correctly. You should see the shelf and you should see the carbon menu. Additionally, we need to have the Houdini engine plugin installed. You can find this up here in the menu bar. If you don't have it loaded, go to Windows, Settings Preferences, Plugin Manager. You can just start typing in H or U for Houdini, and then Houdini engine should come up. I have it loaded and set to auto load. Similar thing, if you start typing in carbon, you see the carbon plugin loaded, and you might want to set it to auto load as well. Let's get started bringing in the geometry we exported from Clo. I'm going to File, Import. Now in my import options, I like to tick group to group multiple meshes which are in a single file. And I also like to untick namespace. Okay, first up, let's select the avatar. Here we go, I can select it and press F and it shows the avatar. This is in a group and I'm just going to name this avatar. We do not need anything besides the body, so let's just hide everything else. Press H to hide, perfect. Let's make this smaller. Now File, Import, and we are going to go down to Start Meshes. Again, we have a group of all the start meshes. Let's change the name to Start. Keep it simple. All right, make it smaller. Now for the render meshes, remember we have exported two. We have export render 2D and render 3D. Let's just start with render 3D. This will take a while because there's more geometry. You can see the progress on the progress bar on the bottom left corner of the screen. Here we are. All right, so we have all of these pieces in here, and I'm just gonna name the group render_3D. Now, one thing to keep in mind is that render 2D will have the same pieces, so the same naming, except for probably the binder trim. Now, the problem is when I just press import, it will not import everything, and I'll show you this now. So keep render 3D as it is, File, Import. We're now going to import render 2D with the same settings. Again, you can follow the progress on the bottom left corner of the screen on the progress bar. All right, there we go. Now we have render 2D, but it only has a transform here and the trim. We're missing all of the panels. This is because Maya automatically seems to detect that the pieces are with the same name it will not import. So how can we bypass this in this case? I'm going to delete this again. And here, I'm just going to add a prefix to all of these meshes. Select Render 3D, go to Modify, scroll down to Prefix, Hierarchy Names. Click on it, and I'm just going to choose a prefix. Let's call it render_3D_. Press OK. Now all of these are named render3D_. I can just remove double naming up here. Just keep the parent as it is. All right, now if you go to File, Import, and render 2D, double click again. It's going to load. And here we are. Now we can see the panels. Well, the first thing we might notice now is there's a set buffer issue, so the rendering doesn't look very pretty. Go to the camera settings up here where it says camera and the gear camera attributes. Click on it, and in the near clip plane, you can change this to, for example, 1, or I think let's change it to 5 to be sure it's properly out of the way. There we go. And only when we zoom out this far, it's going to be a problem. But I think this is not bad. We probably won't zoom out further than this. Let's keep it at 5. Now go to our group and just call it render_2D. Perfect. And as you can see, we have all of these pieces in here. Let's press Ctrl S to save the scene. Now we can start cleaning up a little bit. I'm just going to hide the avatar and the start meshes because we keep all of them. But between the render 2D and render 3D, we have a lot of duplicates and we do not need all of them. So the purpose of the render 3D is to keep the 3D objects that will be turned into rigid body. So the buttons and this belt buckle. What are they called? Well, let's select a couple of them and see if we can see a pattern in the naming. Well, it seems that it is Transform 1 and all these NCL. So let's just select all of these and see. Yes, this seems to be all of the pieces we need in 3D. which means we can delete all of the other pieces in here. So select all of this, delete, and again, all of these blended trims, delete. And we're left with only, if you hide, toggle on and off, only the 3D objects, and you can see the other buttons here too. All right, that's great. We could just rename these now into something like Rigid Body 1 or so, but I'm just gonna do the parent. I'm just gonna call it Rigid Body Meshes. All right, let's hide this and collapse it. Let's open Render 2D. So Render 2D is the opposite. We need everything except for the buttons. So let's just select a transform 1 to NCL 11 and delete them. And there we go. Now we have our Render 2D meshes. We just need to split this up because what we want of it, we want the flat panels and we want what we call the details. So all of the binded trim, actually they're called, all of the little stitches that come out of Glow. All right, so let's go create empty group and we're gonna call it details. And I'm gonna select everything that's binded trim and I'll move it into details. All right, there we go. Let's hide this. And now in Render 2D, we have all of the flat panels. Perfect. Let's press Ctrl S again to save. And now we can get started. Before we move on, there's one more thing we need to do. When you export these flat panels from Glow, you end up baking in normals on these flat panels. Later on, when you deform these render panels based on the simulation results, you will see that the normals will still be there locked onto the file and the shading will look wrong. So let's go ahead and just delete the normals. I'm going to select not only the render, but also the details and the rigid objects. Select all three of them. We can also go select hierarchy, and then we want to do mesh display, unlock normals, and then we want to go, this is going to take a second, and once it's done, we want to go and mesh display, soften edge. This will create soft normals. And then we can go to, edit and delete by type, history. And this deletes all the history. And now we're in a good state. Press Ctrl S again to save. And we now can move on to the garment processor. You can create a garment processor either via the shelf or once the plugin is loaded, which will happen, for example, if I create a simulation node. We can see now the plugin is loaded and we have a carbon menu entry up here. And under Utils, there's a carbon garment processor Glow unwelded. Let me delete the simulation again and we can start now. I'm going to create a node here. And we're just going to work our way from the top to the bottom. Let's get started with the metadata XML file. This is the file we've exported from Glow. Remember, we ticked the tick box. So point to the file, which is just here in the Trenchcoat folder, Start Meshes Metadata XML. Perfect. Next up, we need to create a simulation. Well, we've already done one before, so we know what to do. Click on the simulation button, and let's just adjust a couple of the settings. I like to increase simulation subdivisions to 30 to have more conversions. Also, the length scale needs to be adjusted. Per default, Carbon works with meters and assumes that all scene units are in meters. In this scene, though, the way we export it from Glow, these are in centimeters. So, for example, the avatar is 170 something centimeters tall, which means we need to adjust our length scale to go from meters to centimeters. How does this work? Well, we just set to 0.01, so 0.01 times a meter is a centimeter. In addition to this, let's up the maximum linear motion to get it out of the way. Perfect. Go back to Garment Processor. Here in the dropdown, we can now set the simulation. Next up, material. Create a carbon cloth material, which you can find here on the shelf. It looks a bit like a woven texture or a checkerboard. Click on it and it creates a material node. In the material node, you can load and save JSON material files, so your presets, or you can just start fresh, and that's what we're going to do now. Similar to the scene length scale, thickness is per default set, assuming that your scene is in meters. So 0.001 meters will be 1 millimeter. As we already said, the scene is set up in centimeters. So let's just delete 2 zeros and we have a thickness of 0.1 scene units in centimeters, so we're 1 millimeter. Also, I'd like to increase the stretch stiffness to 100 and change the stretch and the bend viscosity to 2. Back to the garment processor and material select. Next, geometry section, and here's where we point to our groups: start, render, and detail. You can open the drop-down, you can scroll down, but it might take a while to find. Here I've start. If there's even more meshes, it can get even harder. For this reason, our drop-downs have a neat feature where if you select something, for example, render 2D, then hold Control, click on the node with the drop-down. You can let go of Control now, and in the drop-down, if you open it up, the first item shown is the one that's currently selected in the drop-down. And the second item shown is the one that you selected in the outliner, so render 2D. This is much faster. Let's do the same thing with details. Select details, hold Control, click on the garment processor, and in the drop-down, details will now be the second option. Perfect. You can press Ctrl S to save the scene, which is always good practice, and move to stage 2. The first thing it's going to do now here is going to ask us if you want to delete the mesh construction history, which was automatically detected. In your scene, if you have a more complicated rig, you might want to not do this and press proceed with history. But here, since we started fresh and I do not have a history I want to keep, I'm just going to press delete history. Next up is the part that we need the Houdini engine plugin for, because we will load a Houdini digital asset, also known as HDA, into Maya. The carbon remesher was created in Houdini, but luckily with the Houdini engine plugin into Maya, we can reuse the same node. So double click on the HDA. It will bring up a new window now that shows you all of the individual assets, all the individual nodes that are in that HDA. And we want to click the carbon remesher. It will now proceed to automatically remesh the input meshes. This can take a second, depending on the resolution of your input mesh. In the remesher, the default parameters will automatically be adjusted by the garment processor to make sure that the output resolution matches your input resolution in number of triangles. You can follow the progress on the bottom left of the screen. As you see, it keeps tracking along, and we're now at already 29-30 seconds. I think in this scene, it's going to take roughly 45 seconds to remesh the garment. The remesher also takes into account the XML file that we set on the garment processor to ensure that all internal edges are being preserved, and also all open edges keep the same tessellation so that existing connections, so stitchings between panels, are preserved and we have the points lining up perfectly. Now that's done remeshing, we can see here's the target triangle number, which was the number of triangles of the original input mesh, and the XML file is passed as well. There are quite a few more parameters, but usually you won't have to adjust these because it's all set automatically. We can now zoom in and you can see that the tessellation here is a quad tessellation that's axis aligned roughly. This tessellation is much more useful for applying anisotropic parameters in carbon. Note that you can also apply anisotropic parameters on meshes that do not have this specific tessellation, so for example Delaunay triangulated meshes. But anisotropic parameters are applied best in carbon when you have a tessellation like this. So I'm happy here right now, and I'm going to move to the next stage. Go to garment processor and click move to next stage. Move to stage 3. Again, this is going to take a second because there's going to be some reordering. First thing I want to do is select and delete all of these sets that were created by the remesher. I do not have a need for this, so delete this and clean up. Next, we can see that our details, our start meshes, and our render panels have now disappeared from the outliner. They've been actually taken into the garment processor under the group. You can see your start meshes original, which are hidden, and there's still the triangle meshes. Then we have the start meshes remeshed with the new tessellation from the remesher. The remesher has been deleted and we have the meshes without history in the scene. We also have the reference meshes, which were the flat panels original, and we have the reference geometry remeshed. And then the format geometry. The format geometry is a combination of our flat 3D panels and our details. Carbon ran a quick proximity test to assign each detail to its closest panel. If you open up one of these, you can see you have our piece, and here you have the main panel. So this one would be up here, and under there is a group called details. So these are all details that have been associated via proximity to the panel. Now this one is empty, so no detail was associated to this panel. Let's go to a panel where we would expect the detail to be. For example, this panel. And let's open up this, and we can see now details is non-empty, and we can open here, and one detail, this binder trim here, has been assigned via proximity to this panel. Now it may be hard here to see if all the mappings were done correctly. So how do I verify this? Well, luckily we're in the right stage for this. Let me just quickly hide the start meshes and the reference meshes so you can only focus on this, on the deformer geometry. Go back to Gamma Processor and you can now see we are in the stage called Edit Mapping. Well, what does this do? It does exactly what we needed to do. We can verify if the automatic mapping was done correctly, and we can make adjustments if needed. What I would do first is take color results. This will create a color attribute on each panel, and it will color each panel in a random color, and all associated details will be colored in the same color. So if you go here, for example, show if you can see, but we have a detail here, and we have the mesh, and they have the same color. So this allows you to visually quickly verify if there are any mismatches. So you're really looking for a color detail that's in a panel of a different color. If you do not see this, you might have your shading model set to shade the textures of the mesh, if there are any. And this would usually mean that this box is ticked, for example, here. So this now is shading with the textures, which they're not here. But if I untick this, we are back to our default view with our colors. These colors look quite nice, but sometimes you have colors that are very similar to each other and you might want to change it. You can just press Change All Colors and will automatically reassign a random color to each panel. Let me click this now. And there you go, each panel now has a different color. You can also make further adjustments on an individual basis. For this, bring up the Edit Detail Assignments pop-up window. And here we go. If you want to change the color of an individual panel, you just select it and you press Change Color. There you go. Every time you click, a new random color will be applied. Now let's have a look at the mapping. I'm just going to zoom in here, and where we have details and we have panels. So what if a detail was accidentally wrongly assigned? Well, let me just make a wrong assignment quickly. I'm going to select a detail. I'm going to hold Shift, select another panel, and go to Change Assignment. The detail now is assigned to the other panel, and you can visually see that the color of the detail, yellow here, is now the same as this. Furthermore, if I go to this panel here, the detail will now have been moved under here. You remember before it was under here, but now it's an empty group. And there are two assigned to the other panel. How to undo this? Well, I select again the detail first, hold Shift, select the main panel, and just press Change Assignment. Once I press, you should see that this detail should jump back down here and the color should change as well. Let's click now. There we go. And we now have our detail back in here, and the color has been set correctly. Having a quick look, I think it all looks all right, and usually it is because assigning by proximity is a pretty reliable process when your panels are flat and none of them are overlapping. So let's just close this window, go back to our Gamma Processor, maybe press Ctrl S to save. Before I move on to the next stage, I might consider not showing the colors and actually deleting the colors. So let me first hide the colors and now press Delete Colors. The reason for this is that when you have the colors, then extra attribute on the meshes. If you have meshes with high resolution, you're going to add a lot of extra data that needs to be stored in the Maya file. So if you do not need the colors anymore, I would just press Delete Colors now. And press Ctrl S, save again, and this went much faster because we deleted all the colors. Now we can move to stage 4. Stage 4 is Merge Details. What does this do? Well, let's have a look at these again. As we've seen, some of these have one detail assigned to the main panel. Or as we're doing earlier, we all of a sudden had 2 details assigned to a panel. But in some scenes, your details might be split into multiple smaller geometries, so you can end up with 1, 2, 20, 100, maybe even hundreds of individual details assigned to the same panel. This will not only bloat your graph, but later on when we create the mesh deformers, it will also create additional mesh deformers for each of them. Because each detail will have its own mesh deformer that will deform the detail based on the render mesh panels. In order to avoid some of the bloating of the graph and the scene, you can go here to this stage and press Merge Details, which means that for each set of details that are assigned to the same panel, all these binary trims that are here in the same group will be merged into a single mesh. But in our case, we don't have a lot of details assigned to the same panels. It's not dozens or anything, maybe 1, 2, 3. So we can just keep it as it is, and that's what I would do. Let's move to stage 5. Maybe first press Ctrl S, and let's now move to stage 5. Okay, this took a few seconds, but actually a lot has happened. First, let me just collapse the deformer geometry so we can see what else is going on the outliner. We now have allowance start meshes and allowance reference meshes. We also have creases, cloth stitchings, and narrow filters, so a full simulation setup. Let me zoom in, and you can obviously see the cloths are here, and we have one cloth for each panel from our start meshes. In addition, we have one stitching per stitch per sewing that was specified in CLO and exported to the XML file. And this uses the data for the points matching as well. And then what we have as well is allowances and creases. So what are those? Let me zoom in here, and here we have the reference allowances. It's easier to spot a lot of these things while I describe it on the reference allowances, on the reference meshes with allowances, because they're in the flat panel space. It's harder to see in 3D. But for ease of use, we have linked them together. So when you make changes, you only have to make changes to one of them, and the other one is automatically linked and receives the same changes. So let's zoom in here. What do we see? Well, we see these spikes. We call them darts. You might also refer to them as saw teeth or something similar. These spikes, they happen on formerly open edges. In CLO, when you sew two panels together on an open edge, you can provide a strength and an angle. But it is actually technically impossible to provide an angle on an open edge, because an angle by definition is obviously on an internal line between two primitives. So for example, here between these two quads. On an open edge, you cannot provide an angle because there's only one triangle. What else would it be the angle to? So what we have to do is we turn these open edges, when angle has been specified with a strength, into non-open edges. This is where the allowances come in. So we extrude along the open edges so that now formally open edges are not open anymore. And now we can provide an angle with a strength, so a carbon crease on these edges here that were formerly open edges but not anymore. So when we stitch together, we do not only stitch the formerly open edges, but we also stitch now these new extra points, the tips of these allowance darts. And that basically glues these two pieces together using the stitching. Then you apply a crease on each side of the stitching. So you apply a crease on here and you apply a crease on the other panel. And obviously in CLO, if you specified a crease of, let's say, 90 degrees, what you would do then here in Carbon Comment Processor is have a crease of 45 degrees on each. So we just split the mirror. So you have 45 applied on here and 45 on the other side. Keep in mind that we needed to extrude these allowances in a certain direction. We're just using the normals and extruding 90 degrees, so along the normal direction, as you can see here. This allows a very good starting position when these come together in 3D, and it makes it very visible to see where the spikes go in the reference position. If you have a look now at the start meshes, and let me just hide the simulation, what you can see is that you have spikes here on these open edges. Let me just fix the lighting. Go to lighting and two-sided. It's easier to see. For example, here on the collar, we have actually two panels come together. And these two panels, we extruded the allowance at 90 degrees each. But as you can tell, these do not have the same normals, which means those spikes, those darted teeth, have not come together at the same position. There is a discrepancy here, which just came from a slight difference in normals. But when we use the stitching, we actually want these to be glued together tightly, meaning no distance between these 2 points. If you go to Garment Processor, we have the section, a master switch for the allowance. And this is linked to all of the allowances. There's a post process called Match Allowance Position. So if I click this now, this will bring the points together of the allowances that match. And this is, again, taking the data from the XML file to make sure that the matching is perfect. So it's pairwise matching. Just to recap quickly, in CLO, when you stitch two panels together on open edges, you can set a strength for the sewing and an angle for the sewing. Here in Carbon now in Maya, what you need to do when you have two panels come together on open edges, in addition to the stitching that just brings the open edges together, if you want to apply a crease, you need to make sure that these open edges are not open edges anymore. Hence why we apply an allowance on both sides of the stitching. So to panel 1 and to panel 2, we apply allowance, we extrude by 90 degrees, then we add the extra points to the stitching and glue them together tightly. Now we have two allowances and we have two crease nodes. On each panel, we can now set a crease, and we set it to half the angle amount that is specified in the XML file coming from CLO. So a 90-degree angle would receive 45 on one crease and 45 on the other one. To make things easier, under the hood, we have actually linked the creases together. So if I just open up some of these, you can see that here, these are normal parameters as you would expect. But if you go to the second one, now you see yellow colors. What do they mean? Well, they mean that they actually are linked in the node graph, so they have an incoming connection. If you right click on this, you can see what's coming in. Start meshes piece 1, creases 0. And if I left click on this now, it will bring me to that node. Remember, piece 1, creases 0. And here we are, piece 1, creases 0. If I disable this now, and I go back to the other one, you can see that it is linked and it has also been disabled. If I want to go back, right click and then left click, and here we are, I can enable. This is the master switch for the other one as they're linked. So I can change the angle here, the strength, and I can even change the color. And the same values will be propagated to the second one. Now, if you play around and you change the parameters, and at some point you want to come back to your original parameters specified in the XML file, you can find these below here in a quick note. Angle from XML 0 and strength from XML 5. So we can just go back here to 0 and reset this, to 5. There we go. And to verify, we click on the second one again, we can see it's adjusted again. You can also visualize the creases. They're currently hidden because there's a lot to see. Let me show you. Here we are. Here all of the creases, and these are also selectable. So you can select the text and you can select the lines. It is easier to select though when you hide the meshes. So let me just hide the start meshes. There we go. And now we see the crease lines. So if I go in here, it can show me crease 10 and also have the name here, crease 10 shape 11. If I go in here now, crease 10 shape 11. Let's go down and here we are. And if I change the color, it will change the color. Now it is red. Perfect. So as you can see, there are a lot of creases and they will happen where the stitchings are on open edges. So if I show my stitchings again, so enable the simulation, maybe hide the cloths, you can see that these are perfectly aligned here. The line matches with the standard stitching points on the former open edges, and then extruded, you will have the points of the extra mesh allowance. And this becomes clearer when I actually show the cloth. You can see these extra points hovering over the collar. These are the points from the mesh allowance. So the tip of those darts. You see that there's no physics draw of the cloth geometry here. This is because our cloth physics draw is set to collision geometry, and we automatically remove the allowance primitives from collision because we only need them to enforce a crease. We do not want them to actually collide with anything. If I was to go to a cloth and then change the physics draw, you can change to soft primitives, for example. Let me see. We can go here and change it from collision surface to soft primitives, and I'm not quite sure which mesh this one is. Let's maybe hide the creases. And we can see now in here that we have the soft primitives, and this would also show now the soft primitives for the allowance spikes. Let me zoom in, my apologies. And you can see here already here the spikes showing the soft primitives. If I now change it back to collision surface, which is the default physics draw, the spikes will disappear because they're not part of the collision of the meshes. All right, now let's have a look at the allowance parameters. Each of these has several parameters. As I said, we set the angle to 90 degrees and you shouldn't change this. The other parameters are width, curve type, and extrusion type. And I will show you how to edit them and what they mean. But we can do this on a master switch on the carbon garment processor. And here we are back to our garment processor. We can set width, curve type, and extrusion type. Let's have a look, and it's easier to visualize again on the flat panels. So here we have a reference panel. What does width mean? Well, width means the extrusion height, basically. So let me change this to something crazy, for example, 10. After you change any of the parameters, you have to press Update Allowance Meshes for the changes to be baked into the mesh. Let me press this now. And you can see that these have now been extruded quite massively. To be more precise, by a width of 10. This is way too large. So what's a good value? Well, a good value is something that gives you an extrusion height of roughly the length of the edges of the internal tessellation. So let's go back and let's try 0.5. Here we go. And this is roughly a similar edge length on these allowance triangles, as you can tell. Similar edge length as the internal edges. You rather want to be a little bit smaller than too large. Let's just stick with this now. Next up, curve type and extrusion type. Curve type is pretty simple to explain. There are options open and closed. on your allowance, you specify an ordered point group, which marks basically a long edge on a panel. Using these points, we are then extruding these darts. Using the points, we are extruding the darts one after another. When your points form a closed loop, you should choose curve type closed. This is for loops. When they don't form a closed loop, so it's for example just an edge here and not all the way around, you should choose open. You should always choose open by default, because if you choose closed, and let me update the allowance meshes, you actually get no allowance extrusion unless you have a closed loop. And I'm not sure if you even have a closed loop in this case, and it doesn't seem like it. If you do have a closed loop, you can always manually go in each allowance itself, for example here, and then change it individually. But let's stick with the master switch, and we're gonna go back to open. Always make sure to press update allowance meshes after making changes to those parameters. And the final one is extrusion type. We have darted or band. Let me show what band means. What a band does, it basically fills in the gap between the darts. The big advantage of this is that it connects the individual darts, so prevents them from swinging too much on their own and gives a better group cohesion and strength to these allowance extrusions. The one case where you do not want to use band extrusion is when you have a panel that will be deforming quite massively, because then these extra triangles here with their surface area preservation and these edges here that will prevent deformation potentially can really fight your deformation. So when you have panels that very much deform during the simulation, you might want to change the allowance for them to be darted. But in general, band allowance is the way to go. Now that we have the allowances set up in a nice manner, we can move on. Let's have a look again holistically. What we want to do is we want to apply creases on the open edges. How do we do this? Well, we create a crease node, but we also create allowances nodes. We have linked some of the parameters under the hood. For example, each allowance, enable and disable, is linked to the crease that it belongs to. So all of these allowances will have a grayed out box for enable. If I right click on this, you can see where it's coming from. It comes from crease 0 enable. If you go to this, it goes here to our crease 0 of piece 1 and it's the enable box. So this way, if you disable a crease, all you have to do is then update allowance meshes, and then automatically the allowance will basically disappear. We will do this in a second when we're debugging the scene and trying to set it up. Also remember that match allowance positions, so the one that matches up the points of the band or the darted extrusion, is a post process and will have to be done manually. So when you press update allowance meshes, I can show this to you quickly by showing the start meshes. You can see again, here's a gap, and then I need to press the post-process match allowance positions, and they will come together. If I press update allowance meshes again, they will be reset basically, and I have to press this again. Just so you know, in case you're wondering why it's resetting it. It's just a manual post-process. In most cases, we recommend doing it, but you might not always want to do it. So now that we have this setup explained, let's just go ahead and start the simulation. I'm going to hide the allowance, start, and reference meshes. I'm going to hide the rigid objects. Before we get started, we should also add a collider, because otherwise the cloth will just fall under gravity. Let's go to the avatar, show the avatar, maybe press Ctrl S to save because we've done this step, and go into the avatar body, select it, and create a carbon collider. Here we are, now we have the avatar. Before we get started with the simulation, we want to make sure to adjust the thickness as well. As for the cloth, you want to remove 2 zeros because our scene units are centimeters, not meters. 0.1 centimeters is 1 millimeter. Let's go ahead, reset the simulation. You can press Ctrl S again to save if you want to, and let's press play and see what happens. Okay, we can see a couple things. The first thing I see is there seems to be a little bit of over-constraint going on in here. The next up is the belt. Let's tackle one at a time and have a look at the belt first. So belt seems to be falling. My guess is we need to bind it. So let's bind it first and have a look if that improves the situation. In order to bind the belt, it's best to select the mesh and then create a binding. Let me show you. I'm going to hide the cloths. Visualize the start meshes so we can see the belt. First, I select the collider, hold Shift, and then I select the mesh in the viewport. Now I have the collider and the mesh associated with a cloth that marks up this belt selected. And I can just press on the binding button. It will create a carbon binding. As you can see, it binds the body collider and the mesh for this piece, which is apparently named 26. For the child point group, let's just select all of them. Also, let's go to properties. A radius of 0 is a very strict binding and is probably going to lead to over-constrained situations. Generally, it's recommended to not use a radius of 0. Let's just get it out of the way and set it to 10, which means each point can move by 10 centimeters. And we control the attachment strength via the stiffness. I'm just going to set it a little bit lower to 1. Let's reset the simulation and see what this looks like. I'm going to hide the meshes again because we do not need them anymore right now. And we're going to show the cloths. Okay, what can we see? So we get a pop on the first frame where the belt creates this wavy pattern. Well, this makes me believe that there's a mismatch between the start and the reference meshes. There's probably more material in the reference meshes than there is in the start meshes. This can often happen in Clo when you actually set a material to elastic, which will shrink the panels in the 3D window without having to adjust the reference meshes in the 2D pattern window. Let's go over to Clo and have a look to see if that's accurate. Okay, so we're back in Clo quickly just to check on the belt properties. If I click on the belt, I can see that we actually have a difference in the shrinkage. Weft is 100, and so no shrinkage, and warp is 50, so 50% shrinkage. And this is not the case for all the other ones. All the other ones have 100, 100, similar to this middle piece, 100, 100, but the main belt is shrunk 50% in one direction, which obviously is the one that's going around the body. Okay, now that we've seen that our hunch was correct, let's go in and fix this. The first thing we need to do is to create a new material for the belt. Let's go ahead and create another cloth material. At this point, we also might want to label the first and the new material. So the first one, we're going to name main, and the second one, we're going to name elastic. And I'm going to move the elastic up with the middle mouse button just under main. And start adjusting the elastic by applying the same parameters as with main originally. Thickness down to 0.1, bring up the stiffness to 1, and the viscosity for stretch and for bend to 2. Also, since now we have elastic where we want the material to be able to stretch and compress, we're going to adjust the stretch, compression, and extension. Let's set the compression to 0.5 and extension to 2. Also on the surface, just give it a little bit more freedom, 0.5 and 2. Now, in order to apply the shrinkage that you get in Clo, we need to adjust the stretch equilibrium, which tells it to shrink based on the reference by a ratio. But we do not want this everywhere. We only want this in weft direction. So let's go to the weft warp bias parameters, and the first one is weft, set equilibrium to 0.5. Alright, now before we can simulate, we obviously need to apply this material to our cloth. If you remember, it was cloth piece 26. So you go down here to piece 26, go to the parameters, and in the drop down for material, we just change it from main shape to elastic. Now we can reset the simulation, but first let's go to frame 1, maybe Ctrl S to save, reset the simulation, and now let's go. Alright, this looks much better already. The belt is not having this wavy pattern where you have the reference and start matrix fight. But what I can see is that the belt seems to be attached, but the cloth under it still seems to be moving quite unconstrained. I think what we need to do is bring the belt in a little bit tighter. The binding, I think, holds it in place a little bit too much. So let's go back to the binding. And to just bring it in a little bit tighter, we can override the reference distance from the avatar. We just use this tick box to activate use surface offset. Let's just choose, let's say 1 centimeter. So each cloth is about 1 millimeter thick, but there seems to be a bunch of layers bunched up. So let's just try to bring it in a little bit closer than it is. Let's have a look, reset the simulation and press play. Okay, this seems to squeeze a little bit tighter and I'm quite happy with it. But obviously, if you want to change it, you could always adjust it. You can make the belt a bit thicker, a bit stiffer for the bend stiffness to give it a slightly different behavior. But I'm gonna be fine with this for now, I think. Let's have a look what else is going on. So now we can see down here we have our problem situation. It hasn't improved. Let me scrub a little bit. You can see there's definitely some fighting going on. Okay, when you see fighting like this, there are usually two root causes. Number one is collision. So if you have multiple panels overlapping collision, or for example, a garment inside an avatar, you can end up with collision fighting each other and stuff being stuck inside each other and it's trying to come out, but maybe can't. The second possible cause could be over-constrained from constraints like stitching or binding. Imagine you have a point and one stitching pulls it in one way and the another stitching pulls another way, and they're just fighting, and then you get this kind of back and forth fighting. And then you can also have the combination of collision fighting, stitching, or binding constraints. So imagine you have a binding or stitching that tries to pull cloth a certain way, but it actually can't because the collision is preventing it from going to that position. So one thing we can do to quickly see if it's a combination of them is go to the simulation. Let me go back to the first frame first. Go to carbon simulation, and in the section that says detangle, set detangle from all to none. And if this improves the situation quite a lot, that's a very good indicator that you have constraints fighting collision. So let's go have a look. Reset simulation and press play. And this is already way smoother and looks really great. Now at any point during the setup, you can just decide this is good enough for me and I do not want to carry on with all the other details. But I'm just going to show you a few things and how to debug things and how to tackle certain situations. So if you're happy with this, you can move on to the next section where we're going to apply the rigid bodies and the deformers. If you want to see how to tackle certain over-constrained situations and deal with issues, just stick with me and we'll walk through it. All right, now that we know Detangling fixes this, let's go back to all, reset simulation. If you press play again, we can see it looks not so good anymore. All right. It's not too bad, but you definitely want to make this calmer. The first thing I would try is to now increase the simulation convergence. So make the solver work a little bit harder, and maybe that can actually solve the issue. I can see our scene here, the timeline is set to 24 FPS. So each frame in the timeline is a 24th of a second. I'm going to change this now to 60, which I usually recommend when you have any kind of character work or moving characters, because it improves the collision detection. Now, the first thing you can see after moving to 60 is our start frame is not 1 anymore, it's 3. So let's rectify that and go back to 1. There we go. Also, I will increase our simulation subdivisions from 30 to 50. Maybe press Ctrl S to save, reset the simulation, and let's see if this improves the whole situation. All right, this might have made it even worse maybe, because if you have some over constraints, increasing this could actually just make the simulation bang its head even harder on it. But I think we should keep this and just now move on to the next stage. I'm going to have a look now at the collision. Let's go to our material main and remove self-collide. And since all the cloths are linked to this, removing self-collide on this material, we remove self-collide from all of the cloths here. Self-collide just removes collision between a cloth and itself. All cloths and avatars can still collide with each other. Let's reset the simulation again here and see if this improves the situation. Okay, I don't think that's really it. So we can go back. Maybe let's turn it on before we forget about it. And what else can we do? Well, we could try removing all collision. So all collision need to be removed actually on each cloth individually, where you have the collision section activated. This is not part of the cloth material. But I do not want to manually click for all of these cloths, so I actually have a script provided that will do this for us. And let me just bring this over. Here's a little script. It's a Python script. What it does is select all cloths that I've selected in the outliner, which we'll need to do in a second. And then for each cloth, set collision activated to 1. Obviously, we want to deactivate it, so set it to 0. Now to select the cloths group node, go to select hierarchy and all cloths are selected. And I can now run the script. And all cloths have now activation set to 0, which means there's no collision of any cloth. If I reset the simulation now, what you will see is that the physics draw will change. So the physics draw has changed because we have no more collision, and then it defaults back to soft primitives. But now without collision, the cloth will just fall down. So let's remove gravity, and we can probably just hide the collider as well because there's no point of seeing it. Let's go back, Ctrl S, save the scene maybe, go back, reset the simulation, and press play. All right, we can obviously see it's slightly shrinking because the reference metrics bring the cloth together again. But what we do not see is here a lot of things pulling over left and right. So we know it's definitely collision fighting the constraints. Next step, let's reactivate the collision. On our simulation, I can go to minus 9.81. To reset the gravity, we can bring the body collider, select the cloths, go to select, hierarchy, and now here in our script, change activated to 1. Activation has been set now for all of them again. Let me reset the simulation again. You can see the collision surface is now the active physics draw again because we actually have collision. Press play again and we should see the issues. Okay, let's try to simplify this a little bit more to get to the culprit. Well, what's next we can simplify? Well, it's the creases, because creases drive the allowance. So by removing the creases, we also disable the allowances. We get rid of the extra band here, and we get rid of the extra stitchings, and we're not enforcing angles from the cloth file. So how can we get rid of the creases? Well, similar to the cloth, we'd have to click enable off on each of them, and some have actually a lot of tick boxes. But no worries, I got another script, and I will share the script obviously below with you as well, so you can just copy and paste them. All right, here we are. So remember that for every stitching, we actually have to add 2 allowances and 2 creases to be able to enforce the angle. To make it easier, we linked the enable parameters of the creases. So one crease drives the other crease enable, and it also drives the associated mesh allowances. So we can just not go through all the creases and set enable, because if we do this, it will error when it detects a crease that already has an input, and you cannot just change it here. So what we have to do is just check, do we have a crease that doesn't have an input into enable? If yes, set it to 0. Similar to cloth, let's select the parent, go to select, hierarchy, and run the script. Now all of these have been ticked to 0. Let's go back to the simulation garment processor here. And we need to update allowance meshes. And then we also don't need to do match allowance positions because the allowance should be gone now. Let's reset the simulation, have a look. Here we are. Not sure if you saw this, but the extra points that were around here have now disappeared because we don't have a mesh allowance anymore. You can also verify this by showing the reference meshes and looking at the back and see if you see any more spikes. Well, we can tell their spikes have actually not all gone. There are some spikes in here, and this seems to be an issue with the graph evaluation. So let's try running the same script again to see if a second time does the trick. Run it again, go back to garment processor, and click update allowance meshes. And there we go. So we had to run it twice apparently for it to take hold, but let's keep that in mind. But now we see that the reference meshes have no more of the bands and we're good to go. Reset simulation, and let's see if this fixes the problem. And we can see we still get these issues. So the next thing you want to look is actually the stitching parameters. So all of these stitchings in here have obviously parameters. We do not want to do them individually, even though we could. But we have, again, similar to the allowance parameters, we have a master override on the garment processor. Let's have a look at the parameters. Stiffness controls how stiff each individual stitch is, so putting 2 points together. Let's just decrease it a little bit to give it a little bit more flexibility. Compression is set to 0, extension to 0, and equilibrium to 0 in this case. Compression 0 is fine, but setting extension equilibrium to 0 really tries to enforce a 0 length stitching. So 2 points to perfectly match up in space together. We counter collision by adding narrow filters between the pair. But what we're missing here is collision between other panels that might be involved in the stitching or might be clamped in between. The first thing we can do now is have a look at this button here that says create missing narrow filters. What it does is help in these situations. Imagine you have a panel here with an edge, let's say call it A, and you have 2 other panels with similar edges B and C that are both stitched together to this one. In Claw, you would set up a sewing from A to B and from A to C. And also that's the data that is being exported in the meta file. Now when we load this in, we create a stitching from A to B and A to C in narrow filters between those. What we're missing is that with a 0 extension, 0 equilibrium stitching, B and C will also be close together, so by a distance of 0. But we never filtered any collision between B and C. And that's exactly what create missing narrow filters does. It creates narrow filters for these points of B and C. Let's go back to the first frame, then Control S to save, and let's press this button to create the missing narrow filters. It wants to now ask if it should merge with the existing ones, in here the narrow filters, or it should create new ones. So there are a couple considerations here. If you click merge with existing, you will only add a new narrow filter to the narrow filters group if there has not been if you do not have a narrow filter yet between the cloths that contain groups B and C. Otherwise, it will create a new one. If you create new, you will create a completely new set of narrow filters. So you can then later delete them and you never lost your progress to the original narrow filters. There's one downside though. You have to keep in mind that narrow filters between pairs under the hood only exist once. So you cannot have two different narrow filters between cloth A and B. You might have multiple in the scene graph, but under the hood they will be merged. The one issue is that if you have activation set to different parameters, so one is activated and one is not activated, you can end up in a situation where you have undefined behavior and you do not know which of these will actually be taken. I do not intend to change the activation of any of the narrow filters. If I do not want the new ones, I will just delete the group. So let's go ahead and press Create New. And here we are. If I open this up, you can see that it actually has created quite a lot of narrow filters. So let's see if that fixes simulation. Let's press Ctrl S to save. Press Reset Simulation. Let's go ahead. Okay, this did not fix this situation. Let's go back now and adjust the stitching parameters. In our stitching, we have compression and extension equilibrium set to 0, as I said before. So let's not force a 0 length, meaning set equilibrium back to 1, which will take the equilibrium of the original point distance. So it won't change the distance at which points are together. This can actually be very important for complex garments because sometimes cloth, when you have multiple layers in between, will not be able to fully stitch two panels together. And there will be a gap between the stitched edges, even in cloth, when it just can't close it. So by us forcing the equilibrium to 0, it would actually force to do something that cloth couldn't quite do in the garment construction. So let's set it to 1 to not mess with the distances as they came out of cloth. In extension, I would actually give it more freedom. Let's just set it to 10 so that stitches can actually slightly stretch. And we can just control via stiffness how much it will actually stretch. Let's preset simulation and have a look again. All right, this actually looks beautiful now, and we're getting a nice result here. It's calm, we do not see anything pulling, and this is very nice. So we know that now we have a nice setup, but we still have our creases disabled. Let's go ahead and have a look at our creases and see if we can enable them again. This is another point where you can jump off if you choose so. If you're happy with this look and do not feel like you need to enforce extra creases on here, you can just keep going to the next stage where we're adding the rigid objects and then later the deformer geometry. But if you want to bear with me, we're going to have a look next on how to re-enable the creases and tune the parameters and deal with any issues. Let's go back to the first frame now. We probably want to press Ctrl S to save our simulation. And we need to reactivate our creases. Let's bring back our script from earlier. Here it is. Instead of 0, you want to obviously run it as 1. I'm going to run the script. And then I'm going to go here and press Update Allowance Measures. Let's have a look if we have received all of the extrusions, and it doesn't seem like it. Let's just added some of them. So I'm just going to run the script again, come back here, run again, press Update Allowance Measures one more time, and see if we have our allowances back. They're still not back. Let me try press Enable again, and update allowance measures. There's clearly a slight issue with the graph not being evaluated properly, so let me show you another script by doing a little bit more. All right, here's a script. We set enable 1, we set the DG30 for the crease, and we're going to make sure to also tick update on the allowances. So let's see if this is a bit of a sledgehammer approach and works. And there we go. We have our allowances back now. Let's just run it one more time to be sure. Okay. So I think there's just some issue with the graph not properly evaluating, and I will pass this script with you as well so you can use it if you need to. Maybe on your end the graph works better, maybe on a newer version of Maya or something is different in your settings, but for me it seems to sometimes struggle to pass on the data. Let's put the script editor to the side again. Reset the simulation, and if you go back here, we see our allowances have popped up again. Now it's very important, since we set the equilibrium to 1 instead of 0, we need to make sure that our extra points are actually matching up for the allowance, so that we have the pieces glued together properly. So make sure to tick match allowance positions. And this also reset the simulation, and you can see the dots are now together, so they're perfectly lined up. And we can see that also by showing the start meshes, that now this band has come together nicely. I'm going to hide the start in the reference meshes now. Zoom out. Let's press Ctrl S to save. Reset the simulation from the garment processor and have a look what it looks like. Okay, this looks better than before, but we still have a little bit of pulling. So remember that in Clo, I explained earlier before we exported that when you have turned sewings set, that actually this does not export properly in the metadata file. It's a bug in Clo. So it could be that we just missed to set one of those. So I would go back to Clo and see if we can fix this there. If not, we can just disable some of the creases here that seem to be causing the issue. How can we find now the creases that might be the culprits? Well, we can see that it's up here, and we could just select the stitchings that are responsible for that. Then we go back to the first frame. We can see we have a couple of stitchings here that could be responsible for the issues. It might be easier as well if we hide the cloths. Let me hide the cloth. We can see now that we have a few stitchings here, and we can show the creases that match these. Let's go ahead and figure out which ones of these it might be. Well, we have a bunch here up front, and that's where the main issue is. It might be easiest to actually start from the stitchings. So let's have a look. All of these stitchings, you see points aligned with the crease lines, using the extra points. This means that we have the crease activated and we have the allowance. Stitchings are selectable as well. Click on the dot for this stitching, or select it via this, and it will bring us to the right stitching here. This is highlighted. Let's go to the stitching, and the points are actually coming from the allowance. So now we see we have piece 9, allowance is 0. Now we have piece 9, allowance 0. Here we have the name. It's the first one. What is this connected to? Right click again. It brings us piece 9, crease for 5. Now we go down to crease for 5 here, and we can disable it. And you can already see in the viewport, if you look here, that the crease physics draw here will change to show that it's enabled or disabled. Let me take this off, and you can see it's a dotted line instead of a solid line, and a solid line again. If you now go back up to the garment processor, update allowance meshes, and press match allowance positions, you can see that this allowance has gone for this one. Let's just repeat it for a couple of these other creases down here, because these all seem to be causing some issues. Select the next stitching. Sorry, I didn't select it. There we go. Select stitching. Here we are, 109. Go down. Right click on the points. It brings us to P16 allowance 2. P16 allowance 2. Right click enable brings us to P16 shape crease 7. So we go down here to 7. Again, if I disable it, you can see that the draw here is going from a solid line to a dotted line. Perfect. Let's just, before we update the meshes and reset, let's just pick another couple ones. We have this red one here, and there we go. And the same spiel, we just follow the trace. We have 16, allowances 4, so we go to 4, right click on enable, and this goes to P16 crease 9. Let's go down, crease 9, there we go. And again, if I tick it and untick it, we can see the physics draw actually changes. All right, let's have another look. Is there anything else you want to change? Maybe let's grab this one here. Stitching 104. And again, we follow the trail. Right click, P16 allowance for 0. Scroll up, allowance for 0. Right click on enable, P16 crease for 5. And we go down, up here, 5. And we can see the change here in the draw as well when we enable and disable it. I think that's good enough for now. Let's have a look where we're at. Go back to garment processor, update allowance meshes, and match allowance positions. Reset the simulation. Let's hide the creases so we can get to our cloths. Show the cloths. Zoom out. Maybe we need to hide the creases actually fully. There we go. Control S to save. Let's run the simulation. Okay, we can immediately see that this looks much prettier. We don't have any fighting going on here anymore. We have a couple issues here on the sides and up here as well on the collar we can see fighting going on. Let me turn this off. You can see that maybe on the collar we have the wrong angle or it was turned and we didn't fix it. It could be a variety of reasons, but we can just select the stitching. Sorry, we selected too many stitching. Let's see if we can select a single one. There we go. See if it's this one, we can just hide and show it. That's the wrong one. This one, 136, yes. You see, show and hide, seems to be the stitching. So let's just trace this down. Again, right click on the point group, we are piece 10_1, allowances 4. So this brings us to piece 10_1 and we need to go to allowances 4, which is here. Right click enable, brings us to piece 10_1, crease number 6. Now we go down to crease number 6, disable it, click on enable to disable it, go back, up the allowance meshes, match allowance positions, reset simulations, and these extra points are gone now. Let's see what this looks like when we run the simulation. All right, the color looks much nicer now. So we see there's still a few other issues going on. My guess is it's mostly a combination of creases in Clo that have been set to turned and we did not edit the file appropriately. So I would urge you to go back. Or the other thing could also be that we have an angle that's enforced too strongly. Because if you look at some of these creases, let's have a look here if I can find some of these. Well, all of them, first of all, have a strength of 5, it seems like. Strength 5. This might be too strong. So you might want to use a script to just down all of the strength from 5 to, let's say, 1. And have a look. So we could actually do this. Let me see if I can have a script for you. Here's a script similar to the activation. We just bring the strength down to 1.0. Let's go and select all of the creases. Select the parent one, select hierarchy, run the script now, and all of them have to be set to 0. Let's see if this improves the situation. Go back to frame 1, reset the simulation, maybe save the scene and press play. All right, this seems to be a little bit better. But again, at this point, you probably want to just verify your original garment in Clo again. There might just be too many turned ones that have not been dealt with. The other thing that I wanted to mention is, and see if I can find one, some of these angles might be very strong. So if you have some angles that are, these all seem to be 0, but imagine you have an angle that's larger than 90 or 180 together. You could end a situation where the crease tries to force something to turn so much that would actually fight collision with some other objects. So it might be wise to change some of the limits. So increase any angles that is, for example, 180, decrease it maybe to 170, just to give a little bit of freedom. Well, this one was a 0, so let me reset it. The other thing is you might want to go actually to the material. Let's have a look. Let me make the stitching smaller, the cloth smaller. There we go, our main material. And if there's a lot of bending going on, we might want to allow the bend limit to bend by more than 90 degrees. So let's just set this to 160, have a look if this fixes some of the issues. Reset, save the simulation, and go. And this immediately looks so much better. So it was definitely an issue with some of the angles just being too strong or too big. So one could just iterate on this to make it prettier, but always keep in mind the best rule of thumb is it's easiest to have a clean simulation if your starting configuration is clean. So I would go back to Clo and just verify of all of your sewings that none of them are set to turns, and just make sure that all of your angles are set the right way, the right direction, and make sure that your strength is maybe not too strong. Let's call it here with the simulation setup of the cloth, and we're going to move on to adding rigid objects. When you pause the simulation, go back to the first frame. Let's get a nice view here. Let me press Ctrl S to save. I would just hide the stitchings now so they're not in the way, and hide the extra narrow filters. We can also just hide the binding because it's just always here visually present. Let's save again. Now let's start with the rigid objects. Press H to show them. And we got a bunch of them here, as you can see. Before we turn them into rigid bodies for the simulation, let's have a quick look to see if there's any issues with them. Let me zoom in, and well, we can immediately tell that some of this is wrong because the buttons actually overlap with the garment. So you could make a copy of this and provide these as references for your welding if you do not want the buttons to be looser. But I'm happy with just moving the button slightly out and using the attachment as it is then. So let me just go ahead, press W and move this one out a little bit. There we go. Next one. Move it up a little bit. There's a button down here. I'm just going to go through and just play with the buttons and fix them around here in space. Move a little bit out. Over. It's all right. That looks good. Next one. This one is quite in there. Move it out and pull it out a little bit here. There we go. Maybe a little bit over again. Okay. Next one. You can see now the buttons are pretty high resolution geometry, so sometimes it's actually worth simplifying them. This one, you can tell, has 1188 triangles in it, which is quite a lot of triangles. Of a button like this, you can probably use way less. This one, we could actually even put a bit closer. Let's just make sure our buttons are where we are happy with them. That's good. And then one more button down here. All right, we can bring this one closer. Maybe a little bit in here. There we go. All right, that's our buttons, and we made sure there's no intersection going on. Let's press Ctrl S to save. To use the carbon buttons macro, first select the simulation shape, then select the rigid bodies parent node here. Go to carbon, macros, and multi-cloth buttons. It asks you now how many welds you want per button. I'm going to stick with 4. We can always change that later. This is calculating the closest cloth and automatically setting up the buttons. We have the output meshes that are being shown, and we also have the buttons carbon physics nodes. So we have a shape, a rigid, and a body, plus then a welding for each of the geometries. If you click on the buttons node, you can see under extra attributes, it has a master override for all of these that is connected to. So we keep count to 4, that's fine. Radius to 0.1, we could increase it slightly. Let's make it to allow 2 centimeters of radius. Keep the stiffness high to keep them in. Viscosity, maybe 2. And then mass, it's currently set to 0.01 kilogram, which is 1 gram. Maybe just up it a little bit to 5 grams. Also the thickness, very important. Similar to the cloth and the collider, we need to remove 2 zeros because our scene units are centimeters. So 0.1 centimeter is 1 millimeter. Let's press Ctrl S again to save and go back, down to our simulation. Here it is. Reset simulation, zoom out, and let's have a look what it looks like. That actually is working quite well, I believe. Let's pause it and zoom in. Yeah, here we have our buttons and nicely attached. And yeah, I think that looks pretty good. We can hide the buttons physics draw, buttons, and show the output meshes. Here we are. Those are the buttons. What's left? Let's have a look at the garment processor again after we press Ctrl S to save. And there's one more stage left. Apply deformers. Well, if you remember, we still have our deformer geometry. That's in here. And this one contains our flat render panels and details that have been assigned to it. For example, under piece 10, we have a detail that we looked at earlier. So we will create, when we press that, one mesh deformer for each main panel that will be deformed from the simulation result of the matching cloth. And then for each detail under each of these deformer geometry nodes, we will create a deformer, deform the detail based on the render panel. Let's just go ahead and press Apply Deformers. You will now see a pop-up window that's going to calculate the deformers. Depending on how detailed your deformers are, this could take longer or shorter. I believe we have here, if you look here, over 2 million triangles, so this can take a minute or so. You might not need that much. I think most of the details is actually in the details or the stitches, and it's done. Now this doesn't look that great, does it? Well, why is this off? Give it a second to update. It's still not done yet, and I can show you. Okay, here we are. So why is this off? Let me press Q first, so we're in the main selection menu. Right, it is off because our deformer geometry from Clo, the panels, come actually out on a set value of 20. While our reference geometry, we can now look at the remeshed or the original one. Let me just show one of them. Here is actually at a set value of 0. And if I go back, show you one of the deformer geometries, let's go in here and let's show the input mesh. You can see this is at a value of 20. I don't know why, but when you export from Clo, flat panels always have a set value of 20. So all we just need to do is go into our deformer geometry here and change this, translate to -20. This will bring it back. Let me also hide this mesh here and this mesh here, so we don't have them. Well, bringing it back alone now didn't do anything. What we need to do is also update our deformers. But don't worry, we do not have to do this individually. Go back to the garment processor, and there is a button called Update Mapping. Press this and it will update all mappings again. Again, if you have quite a lot of geometry, this can take a minute maybe. Let's just sit and see what happens. It should take a similar amount of time to last time, maybe less, because it doesn't have to create all of the nodes. We're just updating. And here we are. Now this looks proper. Let's bring back the avatar, shall we? Avatar, let's select the parent, go select, hierarchy, display, show selection, and we have all of our avatar back. Here we are now. We have a full setup. You might want to press Ctrl S to save. Press play, and here we have our Trenchcoat simulating and that deforming the render panels. Thank you for watching, and I hope you found simulating with Carbon.